Greetings, everyone. I hope you are all well. Well, today we'll be continuing with vertical projectile problems. My apologies for the one I posted recently. I saw that the problem wasn't really clear, but I hope this one is more clear. I tried to work on it. Well, this problem is from Prep Exam Free State 2024. Well, let's just get into business. A ball of mass 175 gram falls from a tree and breaks the glass of a roof of a wooden cabin directly below it. The ball continues to fall freely until it hits the ground. The velocity time graph below represents the motion of the ball from when it left the tree until it hits the ground. So I'm not really good at drawing, but let's just say this will be our tree. This will be our tree. We have a tennis ball. What did I say? But let's just say we have our ball here. Our ball will fall from the tree, then it hits the glass roof. The glass roof. Then after hitting the glass roof, it will continue until it hits the ground. Yes. Let's say this will be our ground. Let me just use a different color. White ground, maybe. This will be our ground. So our ball travels from the tree. It falls from the tree. So when the ball falls from the tree, it means the ball was at rest. That's why the velocity time graph shows us the initial velocity being 0. Take it as a situation where you mistakenly throw your ball on the tree. Then you want it to like come back down here. You'd maybe shake the tree. The ball would be at rest on the tree. But once you shake it nicely, the ball might fall. So as the ball falls, it starts from the velocity being 0, falling down, increasing with velocity increasing, then it hits the glass roof. If it hits the glass roof, what happens? Now there will be the force that the glass roof exert on the ball, while the ball also exert a force on the glass roof. So that will bring a change in velocity here. Here, let me use a different color. Let's check our graph. Here at time 0.8 to time 1 second, there was a change in velocity. Think of it when you are running, then you mistakenly hit someone. What happens to you? You stop running. When you stop running, what happens to your velocity? The velocity decreases. So this is what happened to the ball. The ball hit the glass roof, then the velocity of the ball decreases. But remember, nobody stops the ball. After hitting the glass will break. After breaking the glass, what happens to the ball? It continues to move down because of what? It's in free fall, remember. So the ball will continue to move down. The velocity decreased, but after decreasing, what happens now? It decreases again because the ball is moving under the influence of gravitational force. So the ball is being pulled down. So after hitting the glass, it decreases the velocity, but will then increase as it goes down because of what? Gravity. Now they say define the term projectile. Okay, I always emphasize that you check your what you call your study guideline for 2025 because they usually change those things, or check exam papers, the memorandums. The recent memorandums will show you the recent definition because they don't change the definition actually, but there are key points that they will know that you should know. So defining this, we say the projectile is the motion of an object that is provided an initial velocity, then moves under the influence of gravitational force only. Then let's move to 3.2. They are saying calculate the distance of the ball, the distance the ball fell from the instant it left the tree until it hit the glass roof. Okay. They want the distance from when the ball was at 0 meters per second until it hit the glass with the velocity that was now 7.4. So I'm just referencing this point. Now we have the initial velocity. We have the final velocity when the ball hits the roof, which is 7.8 here. Then we have the time it took the ball from the tree to hit what? The roof. As I said, where the velocity changes, that's where we show that the ball was in contact with the roof. So now, to get that, let's say this would be, what's going on here? Okay, use it black. Let's use red. So 3.2. They want the distance. The distance, we can use many formulas. Let's use this one since we have everything. We can use this one, which is VF, final velocity squared should be equals to initial velocity also squared plus, please bear with me with the handwriting, plus what? It's 2a, yes, the formula is 2a changing y. So it's just good for you to know your formulas. I just don't have the formula sheet with me, but because I used to have like my formula sheet with me, I got used to the problems. So now we know the VF. What is our VF? At the roof. When the ball hits the roof, the VF is 7.84. And because the initial motion is from the tree going down, I'll take down as positive. Then everything that goes up will then be negative. So this would be 7.84, 7.84 all squared, which is equals to, what is our VI? Our VI was 0, 0 squared, which would be 0. Then this would be 2. Our acceleration, remember, the acceleration is due to gravity, which is going down. And since we took down as positive, our acceleration would be positive. And basically for everything that we'll calculate in this problem, there's a 9.8 change in y. What is the change in y? The change in y is what we are looking for, right? Now, to simplify the equation, our change in y would be equals to, punch it in your calculator, 7.8, 7.84 all squared. Remember just that I didn't put it in the brackets. All divided by 2 multiplied by 9 multiplied by 9.8. So this should give you the value of the distance traveled to hit the red. It's the calculator. So 7.84 squared all divided by 2.98. Then our answer would be 3.136, and you guys are always told to round off to a minimum of 2 decimals, so you can still take 3.136 or 3.14, but to just avoid many decimals, let's take 3.14, not seconds, my bad. That would be in meters because it's distance. So what did they say? They wanted the distance the ball fell from the instant that it left the tree until it hits the glass. So this is not basically the distance from here to here. No, this is the distance from where the ball fell from to when it hits the glass. So it will be the distance from the tree to the glass. Now let's go to the next question. 3.3 or 3.3. What do they want? For how long was the ball in contact with the glass roof? So look at this. I said when there is a change in velocity, that's when the ball was in contact with what? With the glass roof. So the time, the duration would be what? 1 second minus 0.8. It would basically be the difference between 1 and 0.8, which is equal to, and it's a 1 mark question, so you can just write the answer if you want to, which is 0.27. Yes, yeah, that would be what? 0.27. Then we go to 3.4. Now, calculate the average net force acting on the ball while it was in contact with the glass roof. When they talk about the average net force, that's when we go to impulse because there was a collision. The formula for impulse, it's impulse, okay. It's F net. It's F net F net multiplied by change in G, which will be equals to the change in momentum. Change in momentum. Remember Newton's second law in terms of momentum? Yes. So now they want the F net. The F net that was acting on the ball would be the change in impulse, the change in momentum divided by the change in time. So what is our change in time now? The change in time is that difference that we got 0.27. So our F net will be equals to what? Change in P, we'll have to convert our 175 grams to kilograms because this is physics, not chemistry. So 175 to kilograms will divide by 1,000. 175 divided by 1,000. This would give us 0. This would be 0.175 all into, remember the change in momentum, it's mass multiplied by what? The change in velocity, which is Vf minus V initial. So if there is anyone who needs the formula, I'll just note it down after this. So this would be our Vf. What is our V final? Our V final is 1.53. That's the V final. Remember, the initial would be this one because that's when they get into contact. Then when the ball leaves, it leaves with 1.53. And also our times are there. Then this will be 1.53 minus 7.84. This is our change in momentum, all divided by what? Our change in T, we already got it as a value, which is 0.2 seconds. You can still write it as 1 minus 1.8. So what's our answer now? This will be 0.175 multiplied by 1.53 minus 7.84, 0.2 divided by 0.2. Our answer will be equal to negative 5.52. It's with me here, it's 52125, but let me just take 52. This is F net, so it's in neutron. The reason why our answer is negative, it says something. Remember, force is a vector quantity. So what happens here? This is now negative because it's showing us that the force that was acting on the ball is negative. Why is it negative? Because we took down as positive, and the force that will be acting on the ball will be the force that the glass exert on the ball, and the glass will exert that force going upwards. So we will then say what? To justify our answer, we cannot have a negative force. Let's like simplify it and just say our force would be 5.52, which is positive, but okay, this will be positive newtons going what? Upwards. So you just have to write up here, upwards. That's the force that the glass will exert on the ball. Let's get to 3.5. Is it 5 or 6? We are going to 3.5. Calculate the speed the ball reaches when it hits the ground. Now they want this speed. We have the initial speed when the ball was leaving the class. We can now take this as our initial speed because it was leaving the bus, getting into another free fall. So we can say what? This one will just say VF, which will be the speed of the ball when it reaches the ground, would be equals to VI, which is the speed of the ball when it left the glass roof, multiplied by acceleration, adding acceleration and the changing time, the product of acceleration and changing time. So the VI would be 1.53. As I said, this is the velocity of the ball when it left the glass, plus 9.8. Remember, we said everything going down would be positive. 9.8 multiplied by what? What is the change in time? Our change in time would be from 1 to 1.7, which would be what? 1.7 minus 1, which is 0.7. 0.7. Okay. Then our VF would be the velocity of the ball when it hits the ground, which is 3 plus 9.8 or into 0.7, which would be 8.39. This would be our final velocity, 8.39 meters per second. Yes, now let's go to 3.6. Almost done. How does the magnitude of force exerted by the ball on the glass roof compare to that of the force exerted by the glass roof on the ball? Okay, this is how we do it. When the ball exerts this much of a force, it doesn't matter if the ball is small or big. Let's say the pain that will be felt by the roof should be equal to the pain that will be felt by the ball. So the force that the ball exerts on the roof would be equal to the force that the roof exerts on the ball, which means our answer here would be equal. I see the following question. It will ask something that will explain this. This will be equal. Yes. Then 3.7, they are now asking us, name the physics law used to support the answer. We use Newton's third law, which states that when object A exerts a force on object B simultaneously exerts the same force of equal magnitude on object A. So this would be Newton's third law. Newton's third law. Can you please just write it for me because this pen is not friendly. Newton's third law. Okay. I hope you enjoyed the session. If there are any questions or anything that you need to share with me, you can just comment below and I would really